All right, 3.3 is going to talk about two congruence rules, side angle side and HL. So side angle side is exactly what it sounds like. We are talking about two sides and the included angle, and that's the key. It has to be the angle between the two sides you know. If those three things are congruent to the corresponding sides and angles of the second triangle, then the two triangles are congruent. So this picture really says it all. You need to know the sides, and the crucial part is that the angle that's between or formed by the two sides you know. So that angle in blue. This angle and this angle do not count. This angle and this angle do not count because those are not the included angle. So be very careful that you have two sides and the angle in between them. Now, HL is a very special, limited case. HL is only for right triangles. Only for right triangles. You have to know that first. And then if you know the hypotenuse and the leg of one triangle is corresponding to the hypotenuse and leg of a second triangle, then the two triangles are congruent. So we have these two legs and the hypotenuse, and then these will be congruent by HL. And so my congruent statement would be triangle CAB is congruent to triangle. C is the right angle, so Y. And then I went down the two side to Z, and then X is my congruent statement. All right, so what doesn't prove triangles congruent? We've talked about side, side, side. We've talked about angle, side, angle. We've talked about side, angle, side, and HL. What doesn't? Well, angle, angle, angle does not. Okay, knowing three angles does not prove triangles congruent. And if you look at this picture here, the way it's marked, you can see we could actually end up with, even though pictures lie, we could actually end up with a triangle that is smaller than my original. And if we bounce here for a minute to this interactive, you'll see even more so how this doesn't work as soon as it loads. Now here's a situation where you can see the angles are the same, and you can see where I can obviously make this side 1, 2, 3 units, and this one is 1, 2, 3, 4, 5, just over 6 units. If I compare this side right here, which is approximately, let's call it 6.25 in length, and if I look at what would be the corresponding side, it is only 3. And yet, all of the angles remain the same. So this interactive is linked to the Moodle site, so you're free to come back here and play with this on your own. The other thing that does not prove triangles congruent is side-side angle. And if you look at that and you flip the order around, there are no potty words in geometry. Short version of why this is the case, here I have an angle and two sides that are congruent. And what can happen sometimes in this situation, sometimes it will prove them congruent, but in certain situations, I could also swing this length right here, could also end up out here at the same length. And so here I have an obtuse angle, here I have an acute angle, but this larger optional R point is certainly congruent, but this one is not. And again, there's an interactive on the Moodle site if you want to play with this a little bit on your own. But angle, 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 and side, side angle never prove congruence. Now, let's use these pictures, and I have made multiple copies, which is a little different from your notes, but it'll make things easier. Use this picture, it's the same picture, to answer the following questions. So what information do you need to prove them congruent by angle, side angle? Remember, these are the two angles with the side in between. I know a side and an angle correspond. I need the angle here to make angle, side, angle. So what I need is that angle T would be congruent to angle X in order to complete the angle side angle requirements. If I want to know what information I need for angle, angle, side, remember this is two angles and the non-included side. So there are a couple of options for this. Here I know my angle and my side again. So I can do, in this case, angle, angle, side. I need this angle and this angle. I need angle W is congruent to angle Z in order to have angle, angle, side as my congruency theorem. Now, in order to start from that same information again and get side, angle, side, now remember this is the included angle this time. In order to include this angle, I would need to know that side. So I would need to know that VW is congruent to YZ, and make sure your order is correct on that. Congruent statements for these triangles, no matter what order, what theorem we've used, is triangle TVW is congruent to triangle T would correspond with X, V corresponds with Y, and W corresponds with Z. Okay, now again, remember, we could start with VWT, and then our congruent statement would be YZX. Now, given that BC is equal to EC and AC is equal to DC, prove triangle ABC is congruent to triangle DCE. Now, right now in my brain, I need to think about angle, angle, side, angle, side, angle, side, angle, side, HL, and side, side, side. Those are my 5 choices. So I can rule out HL because I don't have a right triangle. What I'm given are 2 sides. So based on what I'm given, that rules out this one, it rules out this one. I'm left to say to myself, can I prove side, 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 or can I prove side, angle, side? Do I know anything about BA and ED? The answer is no. But what I do have, and what I love to see when I have this butterfly picture, is that I have vertical angles. So my first step always, write my given. I find it usually easier to kind of work triangle congruence problems, proofs backwards. Because I have 2 sides, I immediately know I'm looking for side, angle, side, or side, 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 because those are going to fit my theorems in the quickest way. I have this vertical angle bit. That's one of the few things that we can assume from a picture. And so I have BCA is congruent to angle ECD. Pay attention to your order. And that is by the vertical angle theorem. When you go back and look at your picture, you can see that I have side, angle, side. And so I can say that triangle ABC is congruent to triangle DEC by side, angle, side. And that is all there is to that proof. Now, in the following diagram, Midtown is exactly halfway between Uptown and Downtown. Keyword. What is the distance between downtown and Lower East Side? How do you know? Write a few sentences to convince the reader your answer is correct. We could do this like a proof to make our convincing. This key right here, Midtown is exactly halfway. So Midtown is exactly halfway. So that tells us those pieces are equal. If we treat this like a proof for a minute, these two angles are equal by the vertical angle theorem. So my triangles are congruent by angle, side, angle. And if my triangles are congruent by angle, side, angle, then the distance here and here has to be the same by CP/CTC. Now, what would that look? You could either do a formal proof or you could write kind of a paragraph explanation. I'm going to number these two angles right here for our just quick reference. What we're given is Midtown is the midpoint. Sounds kind of funny to say it that way. And that's given. So what does that let us say? It lets us say that Uptown, we'll do it this way, the distance from Uptown to Midtown equals downtown to Midtown. And that's really by the definition of midpoint. What does it mean to be in the middle? Then we can say that angle 1 is equal to angle 2 by the vertical angle theorem. It's tempting to want to go to like HL in here because you see a right angle, but if you don't know that hypotenuse, you can't use HL because angle side angle also works. So then I can't really name them, I could label them, but we'll just say our triangles are congruent by angle side angle. And then we can say that upper to Uptown is equal to downtown. Oops, sorry, wrong way. Lower to downtown. Got to get my correspondence. And that is essentially true by CPCTC because I prove them congruent, then I get their corresponding parts. So my distance is 1.5. Again, a paragraph or a tweak on a formal proof would work great here. That ends our lesson and is the last two congruent statements for triangles.